I am no good at predictions, but I keep up with research. So here are the most important things that I think are coming down the pipeline soon, biased toward computer security and privacy. The first one, and I think the most important one, was the forced entry iOS exploit. This was made by a company called the NSO Group. It targeted iPhones owned by people in the Middle East, and it was probably paid for by the royal family of Saudi Arabia. Nobody knows for sure, but the fascinating thing about this exploit was it took advantage of the JBig image compression library, which is buried way, way, way down in iPhone's operating software. And JBig can do and, or, and XOR operations on pixels. So the attacker took advantage of this to actually build a logic gate, a virtual logic gate out of and, or, and exclusive or. And then they instantiated 70,000 of these synthetic logic gates in the memory of the phone, wired them together into a 64-bit CPU, an actual computer with registers, a load store architecture, and the whole bit, and then executed their malware on that virtual CPU running in the phone. So it was completely invisible to malware scanners. The interesting thing about this attack was that these are capabilities that we would normally associate with major governments. This was developed by a private company as a product for sale. So the Venn diagram between major governments and private organizations, a small firm, is now basically a circle. And we have to consider that this kind of attack that we used to attribute to KGB or CIA or NSA or Mossad is now within the capabilities of individual companies. So again, this isn't a prediction. It's just, these are interesting things that have happened in the last few months that maybe not a lot of people have heard about. Car security. Everybody knows that well, maybe not everybody knows that police departments are using access to basically car flight recorders. Your car is keeping track of how fast you drive and braking events, turning events, accelerometers and such. And cars store an awful lot of information, and police departments are beginning to figure out that they can download that information. Car insurance companies have known this for a long time, but police departments are starting to figure this out. You know, your car has GPS. It knows where it is. And for example, if you take your car to the drive-thru at McDonald's, your car can tell the difference between the weight of the car before and after you picked up a couple of Happy Meals at the drive-thru. But actually, it's much worse than that, because the modern cars have an awfully wide attack surface, and those are just the obviously accessible ones. Wheel speed sensors in the anti-lock braking system, accelerometers, temperature sensors, ice sensors, they could all be potentially used to spoof the engine control management system. So it's just something to watch out for, is car privacy issues around cars. Here's a good one that I am very encouraged by, is early detection of ransomware. Ransomware is a big problem for organizations right now. Early detection of the malware before it really gets going is important. So here we have these researchers found some identifiable patterns in malware execution that can be detected, and potentially we can spot when a ransomware attack gets into an organization. We can spot on the first couple of computers it's executing. If we see these kind of patterns, then maybe we can detect it and stop it before it shuts down the entire organization. This next one is a little weird. I don't really know about this paper. It's just a feeling, but I think this might be one of those historically important papers. It's just a feeling based on the names of some of the people attached to this. But I think this might be a very important paper someday. It's just a feeling that there is something like the Heisenberg uncertainty principle going on in differential privacy. And there are trade-offs between how much information you can protect versus how much information you leak. Here's a neat one. It turns out you can detect hidden cameras by retroreflection through the lens system, sort of like animal eyes shine in the dark. This is a privacy protecting technology. Can run on a smartphone. You simply wave it around the room and you can detect the presence of hidden cameras. Related to that, here's another interesting paper just from a short time ago. They trained a computer vision system to recognize surveillance cameras in Google Street View, and they turned it loose to map them. It automatically recognizes CCTV cameras perched all over and estimates their field of view, then annotates the map to show which areas of the street are under surveillance and which are not. I just love this paper because I love the name of it, CCTVCV for computer vision. Okay, here is a very clever technique used in malware. They self-attach a PTrace PTrace system call in Unix and then execute the assembly language instructions in reverse order so that the malicious code looks innocuous to scanners, but it has a completely different effect when the assembly language instructions are executed in reverse. And the best part of this is that as soon as you start to use this technique, you're attaching a PTrace to your own process. No other process in the system is allowed to use PTrace because PTrace can only be instantiated once. So this is just evil, but is oh so clever. Here's another cool one. Detecting malware on IoT devices at a distance by taking advantage of the radio frequency interference that it generates. Computer programmers back in the 1940s, they took an AM radio into the computer room. They wanted to listen to their 1940s, big band radio station. What they heard was a whole bunch of noise coming from the computer, radio frequency noise, whistles and pops and pings and ticks and buzzes. And it turns out that you can't actually listen to an AM radio in a computer room very effectively. This has been known for a long time, but these researchers are taking advantage of that fact. They can tell the difference between an IoT device that's doing what it's supposed to do, being an Amazon Alexa or a Wi-Fi router or something, and one that's actually running malware and doing something different from what it's supposed to be doing. This is very cool, and don't listen to the commenters on Bruce Schneier's blog who tell you it's impossible. I'm a side channel researcher, and this sounds perfectly plausible to me. Okay, this is my only actual prediction. I've been telling people for a long time that epistemological security is the new national security threat. That's what I think. Getting more into privacy, small flying drones. How small? How about this small? It is the size of a grain of sand. Northwestern University. It's not able to fly on its own. It can only glide. It has no motor, but it does have its own power source, sensors, navigation, computer, and radio. So this is how small drones can be, flying drones can be in 2022. Okay, information leakage, one of my favorite topics. This is information leaking out of intelligence agencies in other governments. These researchers looked for patterns of use in redacted documents that national intelligence agencies, US, UK, Germany, France, Italy, the Netherlands, they studied about 20 different intelligence agencies, and they could actually see patterns in the redacted documents that these agencies were releasing. They could see, for example, changing patterns over time in what operating system the government agencies preferred to use for their to run their redaction tools on. They could see it changing from mostly use of Mac OS in the early 2000s to overwhelmingly these agencies were switching to Windows. These are national intelligence agencies leaking information. I just think it's fascinating. Here, they can even identify individuals by individual users within those classified government agencies by their tool use, not by name, but by profile. This graph shows at least 3 distinct individuals working in classified government security agencies, identifiable by their activity patterns. I just think this is great. Intelligence agencies leak information. And that's all I've got. I will give you a complete list of sources if you want to look up where all of these papers appeared. Gabe, I'll upload those slides to the in a comment on the Meetup website as soon as we're done here. That's all I've got. Thank you very much. And back to you.
Thank you, Joe. That was awesome. Does anyone have any questions?
I just have a comment that, well, my comment is that through Joe's revelations here, I think we've been seeing for the last decade or so how technology is being exploited, and through the proliferation of a technology like the IoTs. Like, so we all know that it's like well, I have a thermostat, and I play my music through a smart device, and my TVs can controlled by a computer, and as Joe was saying, car security. So it kind of portends a scary time in the near future where we'll see malware and the bad people who are using it take advantage of the normal people like us.
Yeah, I'm glad that you talked about NFTs, because I think NFTs are dumb. But back in 2007, I remember hearing about a new social network called Twitter. And my reaction to that was, that's dumb. So nobody will use that. So, don't trust my predictions.
Yeah, I really didn't think Twitter would catch on. And when the metaverse came out, I was like, this looks like Wii Bowling, but what do I know? Joe, I have a question. The drone that's like ant-sized to an ant, what would you imagine that would be used for? Just surveillance, or?
The researchers at Northwestern who developed it want to use it for measuring like microclimate environments in a forest. You could make 10,000 of these and just scatter them out of the back of an airplane. They drifted down into the forest, and they're constantly sending back information from their temperature and UV sensors, for example. That's the kind of application that these things are potentially, are intended for. I just rather expect that military applications will be found just as well. And I guess the idea is you can make tens of thousands of these and just fog them over an entire city. They don't have very powerful radio transmitters because they have a very small power budget, but they use mesh networking so that if an individual sensor device has found something interesting, if it's within radio range of any of its peers, it can send the information to them, and then that sends it to the nearest one that it can hear, and eventually the information filters back to the base station. So they're very simple, and they can't do much, but if you can make them a million at a time, maybe this is an important technology.
I heard several years ago about dropping sensors like this, say like in tornadoes and hurricanes, right, for doing an analysis. Maybe not the micro scale ones, but this also makes me think about the environmental pollution that these things could cause. And so imagine them getting into your food and then you swallow them, and then what they could do.
Sure. Every time I go to the doctor, I ask, so when are we going to get the little robot submarines that swim around in my bloodstream and keep track of my health? And the doctor keeps saying, it's 5 years out.
My
Like what, 20 years ago? I forgot the name of it, with Martin Short. It's hilarious.
one last question for me about the as a layperson, I've always been very concerned about the fact that modern cars seem to have a really wide attack surface, like, and I was wondering how car designers have accounted for that and how this could have happened, because it seems like driving is one of the most dangerous things that people do. So my question is, how did this happen with modern cars?
Well, modern cars run Ethernet under the hood. They run a couple of different communication protocols. One is called CAN bus, which is used for for example, the engine control computer talking to the throttle, talking to the wheel speed sensors. But they also run Ethernet, and very often they tunnel CAN bus over Ethernet because it's cheaper to run one set of wires. But it happened because everybody wants, to be able to watch DVDs in the backseat of the car. And it was, well, wiring is expensive and it's heavy. So they wanted to minimize the number of connections so that the wiring harness in a modern car doesn't, weigh more than the car itself. The exact same thing happened in airliners. A friend of mine, Chris Roberts, was the person who first plugged a laptop into an Ethernet jack that he found underneath his seat in row 27 on a Boeing 777. And he found that he could see with an Ethernet sniffer, he could see packets going back and forth that looked an awful lot like navigation and engine management data. Converged networks, they are a fact in airliners, they are a fact in cars. And for example, if you want to attack a car, probably the easiest way to get into it is through the tire pressure management system, the TPMs, because the law in the US right now says that you have to have tire pressure sensors on all new cars so that the car can detect if it's got a low, flat tire, and lights up a little icon on the dashboard to tell the driver. Well, so you got to have a tire pressure sensor in every wheel, but it's really hard to put a sensor on a wheel because the wires tend to get wrapped around the axle. So you use a little short range radio transmitter to do it. And that means that your car is constantly listening on at least 4 radio receivers all the time. And attackers have demonstrated it. They demonstrated this at Black Hat in 2016, that they could get in through the TPMs. From there, they leapfrogged into the stereo system. And from there, they were able to get into the engine management control computer. So there are no firewalls between these systems. And I spent my entire career at Lockheed building firewalls for the US government, and car manufacturers are just beginning to learn those lessons. Oh, okay, I'll shut up now.
Wow. Whew. Thank you, Tom. Thank you for your great and also very scary talk.